Hello. Today we're covering cluster analysis, the algorithm that sits underneath market segmentation and makes it actually work. If you've ever wondered how a pile of survey responses gets sorted into distinct customer groups, this is the answer. By the end, you'll understand what cluster analysis does, how the algorithm works, how to decide how many clusters to use, and what you do with the segments once you have them. Let's start with the problem. Here's the challenge at the heart of market segmentation. You've surveyed 500 customers. You want to group them into a manageable number of distinct types, people who are similar to each other and different from the other groups. But with 500 people and dozens of survey variables, you simply cannot look at the data and decide manually who belongs where. The combinations are too numerous, the variables too many, the patterns too complex to see without help. Cluster analysis is the tool that does that sorting automatically, finding the natural groupings hiding in the data so you don't have to. The core idea is simple. Group similar people together automatically. You don't define the groups in advance. You don't decide upfront that there are 3 types of customers or 4 or 5. You feed the data into the algorithm and the groups emerge from the patterns already present in how people answered. Your job isn't to invent the segments, it's to interpret and name what the data found. That's a fundamentally different and more honest approach than starting with assumed categories and trying to fit people into them. Cluster analysis is an algorithm that groups observations. In market research, those are usually survey respondents, so that members of the same group are as similar to each other as possible and as different from members of the other groups as possible. The groups it produces are called clusters. The goal is maximum similarity within each cluster and maximum difference between clusters. When it works well, each cluster represents a genuinely distinct type of person with a coherent set of attitudes, behaviors, or needs that sets them apart from everyone else in the data. Here's the visual that makes cluster analysis immediately intuitive. Look at the scatter plot with a cloud of dots. Your eyes immediately finds the groups. 3 distinct clusters of points with open space between them. You don't need an algorithm to see that. Cluster analysis is just formalizing the same pattern recognition process and applying it to data that has many more dimensions than you can plot on a 2-dimensional chart. When you have 20 survey variables instead of 2, you can't see the clusters by eye. The algorithm sees them for you. Let's apply this to a concrete scenario. PulseApp is a fitness subscription app with a growing subscriber base. The team suspects that their subscribers aren't one homogeneous group. They have very different fitness goals, different usage habits, and different motivations for being on the app. If they can identify the distinct user types, they can personalize onboarding, content recommendations, and retention messaging for each one. They survey subscribers on 4 dimensions: workout frequency, goal orientation, content preference, and motivation style. The goal is to find the natural subscriber types hiding in those responses. The first step before any algorithm runs is deciding which variables to include in the clustering. This is a judgment call that shapes everything that follows. For PulseApp, the 4 survey dimensions were chosen because they capture the behavioral and attitudinal differences most likely to predict how subscribers use the app and what they actually need from it. The rule of thumb: include variables that are relevant to the business question and leave out the ones that aren't. Including relevant variables doesn't make the analysis richer. Including irrelevant variables doesn't make the analysis richer. It adds noise and weakens the natural groupings. Less is often more. Before the algorithm runs, you need to put all your variables on the same scale. Here's why. If workout frequency is measured from 1 to 7 days per week, and agreement ratings are measured from 1 to 5, the frequency variable has a wider numerical range. Without adjustment, The algorithm would give frequency more influence in the grouping, not because it is more important, but because its numbers are bigger. Standardization rescales all variables so they're on a comparable footing and each one contributes equally to how people get sorted into clusters. There are two main approaches to cluster analysis, and they work differently. K-means is the most widely used. You tell the algorithm how many clusters you want. That's the K, and it assigns every respondent to one of those groups based on similarity. It's fast and practical, but it requires you to make a decision about the number of clusters up front. Hierarchical clustering takes a different approach. It builds a complete tree diagram showing how all respondents relate to each other at every possible number of clusters, from one big group all the way down to everyone in their own group. It's more exploratory and useful when you genuinely don't know how many segments to expect. For PulseApp, we'll use K-means, guided by a method that helps us choose K. Choosing how many clusters is the most important decision in the whole analysis, and the elbow method is the most common tool for guiding it. Here's how it works. Run K-means for different values of K. 2 clusters, then 3, 4, 5, 6. For each, measure within cluster variation, how different people within the same cluster are from each other. A lower number is better. It means the cluster is tighter and more coherent. Plot that number against K, and you'll see the curve drop steeply at first, then flatten. The bend in the curve, the elbow, is the point where adding more clusters stops buying you meaningfully tighter groups. For PulseApp, the elbow appears at K equals 4 segments. Here's how K-means actually works in 3 steps. First, the algorithm randomly places 4 centroids in the data space. A centroid is just the center point of a cluster. Think of it as the average person in that group. Second, every respondent gets assigned to whichever centroid they're closest to in the data space. Third, the algorithm recalculates each centroid as the average of all the respondents now assigned to it. Then it repeats steps 2 and 3, reassigning respondents and recalculating centroids until the assignments stop changing. At that point, the clusters have stabilized. Each respondent belongs to exactly one cluster defined by the centroid they're closest to. Once the algorithm has finished, you have 4 groups of PulseApp subscribers, but you don't know yet who these people are. The profiling step is where you find out. For each cluster, calculate the average score on every variable and compare the 4 clusters against each other. 4 distinct profiles emerge. Cluster 1, high workout frequency, competitive motivation, strong preference for video content. Cluster 2, moderate frequency, wellness-oriented goals, community-driven motivation. Cluster 3, lower frequency, weight loss as the primary goal, needs guidance and a clear structured plan. And Cluster 4, irregular frequency, self-directed, no fixed routine, prefers flexibility. Those 4 profiles are distinct, coherent, and recognizable as real types of people. Profiles need names, because a cluster labeled Cluster 3 doesn't travel well across an organization. When someone in product, marketing, or customer success hears structured starters, they immediately have a mental model of who that person is and what they need. PulseApp's 4 segments: performance trackers, high frequency, competitive, video-led, always pushing for more. Wellness seekers, moderate frequency, community-oriented, focused on balance. Structured starters, lower frequency, weight loss goal, need guidance and a clear plan to follow. And flexible soloists, irregular, self-directed, no fixed routine, want flexibility above all else. Those 4 names do work. They make the segments usable. Before you act on segmentation, you need to validate that the clusters are real, not just an artifact of the algorithm. 3 checks. First, do the segments make intuitive sense? Can you describe a real type of person in each cluster? If not, the grouping might not be meaningful. Second, do clusters differ on variables you didn't cluster on, like churn rate, plan tier, or subscription length? If performance trackers have significantly longer subscriptions than flexible soloists, that's evidence that clusters are capturing something real and predictively meaningful. Third, if you rerun the algorithm with a different random starting point, do you get similar clusters? Stability across multiple runs is a good sign. Clusters that shift dramatically every time you run them aren't reliable. Here's how PulseApp actually uses the 4 segments. In onboarding, structured starters get a guided 30-day plan with clear daily instructions. That's what they need to succeed. Performance trackers get a challenge leaderboard because competition is their primary motivator. Wellness seekers get invited to a community group because connection drives their engagement. In messaging, each segment gets copy that speaks directly to their specific motivation rather than generic fitness language that resonates with nobody in particular. And in retention, the flexible soloists show the highest early churn risk. They get a proactive re-engagement campaign at day 10 before they've mentally checked out. Let's be balanced. The strengths of cluster analysis: it finds natural groupings and complex multivariable data that no manual or intuitive method could identify. It produces actionable, nameable segments that can be used across product marketing and customer success. And it's widely applicable. Anytime you have a group of people or objects and want to find the natural types within them, cluster analysis is the right tool. The limitations are equally real. K-means requires you to choose the number of clusters up front, and a poor choice produces poor segments. The results depend heavily on which variables you included. Include the wrong things, and the algorithm will sort people on dimensions that don't matter. The algorithm will always find clusters whether natural ones exist or not, which is why validation matters. And segments shift as your user base and market evolve. So a segmentation that was accurate 2 years ago might be stale today. 7 things to take with you. Cluster analysis groups similar people together automatically. The groups emerge from the data, not from your assumptions. Choose clustering variables based on the business question, and don't include everything just because you can. Standardize your data before running so no variable dominates based on its numerical scale. Use the elbow method to guide the number of clusters rather than picking a number at random. Profile each cluster thoroughly so you understand who's in it before you name it. Name the segments in a way that makes them immediately understandable across the organization. And always validate. Check that the clusters are stable, intuitive, and meaningfully different on variables you didn't cluster on before you invest in acting on them. Thank you for watching.